Yeah, hello friends. Sorry for being late for a few minutes. So whoever are here, you can just ping in the chat. Whoever are available in the call, just let me know if I am audible or not. Okay, so today we are going to see the concept of generators and what is the use of context manager. Okay, so these two are very important concepts, and not only for FastAPI, but also this is an important concept for your core Python interview also. So it's very important to get the concept of these things. And if you have any issue regarding any concepts, you can ping me in the chat, or else you can also ping in our Discord group. Okay, so let's start. Let me create one folder. Let me name it as generators. Let me open. Okay, let me know friends if the screen is visible or not. Okay, so let's start. Okay, so let's start with our first concept, that is generators. So what is generator? So this is also the concept friend, in the JavaScript also we have this generator concept. You can also link that with it. So generator is a special function that produces a sequence of values. Okay, and it's lazily. That means one at a time, instead of storing all values in memory at once. So what does this mean? Let's say if you have an array or a list, okay, like say if let's say we have a array or list with a value of let's say 1, 2, 3 up to 100. Okay, so what is happening, like suppose if you want, or if you want a function that will create a list of 100 values, so what you will do, you will create an array of 100 and then you will return the array, right? But what is happening internally, so internally basic it's creating a memory space. Let's say if every integer value is taking 1 KB, then what is the size of the whole data? It's 100 KB, right? Because 1 to 100 KB. And let's say this array will also have some size. Let's say totally it will, let's say it will take 105 KB, let's say, from all the value of 1 to 100. So what does this mean? But in our application, let's say I am using value 1 to 10 initially. Let's say after sometimes I am using 20 to 30 like that. Okay, but the memory is still taking 105 KB from initially. Okay, that means the data is loading eagerly. Data is getting loaded eagerly. So what is the issue with this, friend? So if the data is loaded eagerly, that means the memory location, the memory consumption is high. For that reason, memory consumption is high. So we don't want this. We wanted to minimize this. Okay. So for that, we will use the concept of generator. Okay. So how generators are basically defined? Okay. So generators are basically defined with yield keyword. With the yield keyword. So generators are basically a function, friend. Okay. It's just like a function, but the difference is, I'll tell you. So what is the difference? So there are a few key difference with the normal function and generator that I will say, but in a whole you will think generator is also a function, but it will use a yield keyword instead of return keyword. Okay. And how it works, friend? So basically, in the working principle, in normal function we use return keyword, right? But in generator we use yield keyword to return any value. Okay. Here, so normal function will execute at once, like all the code inside that will execute at once and it will return the value. Okay. But in generator, what will happen? It will pause the execution and can return multiple values over time. That means it can pause the execution and can return multiple values over time. Okay, just see, friend, multiple values is one time and over time. That means after like 1 minute, 2 minutes, whenever we require the value, that time only it will emit the value. This is one of the key difference between a normal function and a generator function. In case of memory use, friend, normal, it will take much less memory than normal function. We will see this. Okay, we'll see how it will take the less memory. So these are the few difference between a generator and a normal function. So okay, first let's see how a normal function works, and then we'll see with the generator function. Okay, let's go here. So here let's first type basic.py, the generator function. So let's first define a normal function. Let's say we wanted to create an array of or list of 100 numbers. Okay, then how you will define? We will write def, let's say create numbers. Okay, so let's say we are taking one numbers list, and then to add numbers from 1 to 100, what we can do? We can loop over it, right? We can loop 100 times and can add the value. Let's say for I in range from 1 to 101, and we are going to add the value into this numbers array. So numbers dot append I. Okay, now we are returning the numbers. So we have created a function, friend, where we are creating a list of 100 numbers and we are returning the number. So what it will happen? It will return all the value at once. Means all the value will be loaded in the memory at once and it will return the value. Okay. So how we can do? Let's say with the result, we can call this create numbers. If we print it, let's change it to iterating. Here we can write Python basic.py. Here, see, we are loading all the 100 values at once itself. Okay, all the value is loaded into the memory at once and it's loading. But then, friend, if this is 1 to 100, but what will happen if there are millions of data? So millions of data will get loaded into the memory at once, and it will cause a memory fluctuation error, or maybe the system can crash also. Okay, if the system or the server has not so much of capacity. So for this reason, we use the generator function. So how to use a generator function? So we will create same way. We can create a function. Let's say create numbers, but with generator. Then we will loop again. Okay, for I in range of 1 to 101. But now here, instead of loading value from 1 to 100 into a list and return it, we'll use the keyword yield I. So what it will happen with the help of the CL keyword? So how it will work? So let me give you an example. Let's say if the for a normal function, what will happen? It will load all the data at once and it will give me the result, right? But for the yield, what will happen? Let's say this is a generator function, okay, and I am looping, let's say 1 to 100, okay, and inside it I am yielding, let's say first 1, yield 2, because in the loop, right, in the loop I am yielding, okay, like this up to yield 100. So whenever we will call this generator function, let's say response 1, we will call this generator function. So you will not call this like this. I will show you how we can call this. But whenever we will call this generator function, it will return only one value at a time. Okay. So first it will print 1. Again, if we need the next value, we need to call it again. Generator. Then it will return us 2. Okay. So one value at a time. This is known as lazy evaluation. That means all the data are loading lazily. Okay. It's not getting loaded instantly, all the value from 1 to 100. It's getting loaded lazily. Whenever we require the value, we are calling that. Okay. Then we are getting the value from there. This is the concept of generator function. Now how to write that function? Let's see. So here we have created, right? We are yielding it. Now let's say we want to call this function. First, let's see. We'll write gen equal to getNum generator. First, let's see what it gives. So see friend, here it's not giving me anything. Okay, sorry, I haven't printed it. Okay, see, it's giving me a generator object. Okay, that means it is giving me a generator object. From there I need to extract the value. Okay, that means a generator function will give me a generator object. It will, every time it will yield, or the whole reference, it will give me a generator object. It will give me a generator object, and from the generator object we need to get the value. From this generator object we need to get the value, right? We need to get this value. Now how to get the value from this generator object? So for that we use the next function. So we'll use a next function. Okay, the next function will basically call the next yield. So what will happen? First time generator function next is called, the first yield is executed and the execution get paused here. Okay, that means first generator function, this yield is done, it returns the value and it got paused here. So it got paused here. So when it will resume again, whenever I am calling the next generator function again, then again it will resume. All the code will be executed between this, and when it will again face a yield statement, it will again return the value and the execution will pause here again. Okay, in this way the generator works. So here we have, now we have created a generator object. Now to get the value, what we can do, let's say first I'll write print what is the function next of generator function. So next of generator function means what will happen, friend? So first yield is executed, that means yield of I, that is 1. See, 1 is executed. I am getting one value at a time. I am not getting 1 to 100. Now if I want the next 2 value, what I will write? So for the next 2 value I will write again next, then the generator function, again write next, the generator function. Now if I run again, see, now I am getting 1 for this one, this is giving me 2 and this is giving me 3. So I am loading all the value lazily. Whenever I require the value, that time I am only fetching that value. Okay, So any issue friend till now, you can let me know. This is the main concept of a generator function. And if you want to get all the value at once, how you can do? You can use the loop concept. So you can write for, because one thing friend, generator is iterable. Okay. So let me tell you. Generators are iterables. That means we can loop. So here we can loop over the values. So we can write, let's say, yeah, for numbers in, we can call this method, and we can print the numbers. See, we are now printing all the value at once. Okay, we are looping through it and printing all the value at once. In this way also you can print, but if you want only specific value at a time, go for the next function. Okay. Now another thing, let me tell you. So if you print directly this generator function, okay, let's say print this create generator function. So what it will give, we have already seen it, right? It will give me a generator object. Okay, see, it is giving me a generator object, right? But if you wanted to convert this to any array or list, anything, what you can do, you can just convert it directly. So you can typecast it. So just typecast this to list. See, now the whatever the function it's returning, it's now typecasted to list. Okay, but what it will happen, friend, if you typecast this to list, that means this is losing the capability of generation, like the lazy loading. So if you're converting this to list, that means the yield function will lose its capability and it will load all the value from 1 to 100 in the memory and it will send us the value. Okay, so avoid this possible, but yeah, in few scenario you need this, you need to convert this to list. But yeah, for the purpose of your knowledge, I am showing this also. In this way, you can convert a generator into a list also. So any issue guys till here? Let me know. Okay. Now another concept, let me give you. So in generator function, like in normal function, we can write one return statement, right? Only one return. But in generator, you can write multiple yield statement. Okay. Let's say def test generator function. Let's say yield 1, yield 2, yield 3. Okay. See, I have written 3 yield statement. So think friend, yield is also similar to return function. Okay. Now to call this, let's say I'm calling again g equal to test. Okay. So it will return a generator object. To print the value, first value, what I need to do, print, I write next of g. Okay, I'm getting the value 1. To print all to these two value, what I can write, this will give me 1, and then again the next again will give me the next yield statement. So this one is giving the first yield statement, the second one will give me the next yield statement. So basically the generator function knows from the last execution up to where it have executed. It will start after that only. Okay, that will show in the next example. G. It will give us the second value. See, I am getting 1 and 2. Now for the next, to get the value of 3, it will give me the value of 3. But what will happen if we call again? So now after this third yield, there is no yield statement, right? So what this will give? So this will give us an exception. Okay. What is that exception? That is known as stop iteration. That means if you are looping or anything, it's telling there is no more data to yield. This is the end. You can stop it now. Okay. Let's see. See, it has given me this as 1, 2, 3. But the final print next statement is giving us a stop iteration error. It's telling there is no value to yield. So all the yield has been completed. It has now stopped. So for that you can do the exception handling. Like you can use the try and except block. So for like this you can do try. So instead of this, you can wrap all this inside the try block and create an exception block, except block. So what type of error it will raise or exception it will raise, right? It will raise a stop iteration exception. So you can write stop iteration exception. Okay. And here you can write print all values got generated. Okay. See, 1, 2, 3, these 3 are printed. This has given us a stop iteration. Since we are doing an exception handling, so it got handled in the exception. All value got generated. So this is another point, friend. So this is the 5th point. When all values got yielded, that means generated, it will give stop iteration exception. This is also an important point, friend. Okay. Now let's see the concept, like how it's get paused, those things, right? So I have told you that the generator function get paused and it knows like last time up to how much it has executed. Let's see that example now. So let's create a function def, let's say pause resume. Okay, demo. So let me give a first visual explanation what it will happen for the pause. So I'll also ask you, friend, just try to answer. Let's say this is one generator function. Okay, let's say this is one generator function. Here this is, let's say, pause resume that function. Okay, inside this I have this first yield some value is there. Okay, let's say yield 1. Then I have written print a. Okay, and here also let's say I have created print something started. Then I am doing yield 2 like this. Okay, yield 2, then again print statement. So how it will execute? Okay, so what I have told, friend, let's say g equal to, I am calling this pause resume function. So to get the first value, what we need to call? We need to call the next statement, right? So r equal to next of g. So what this will do, friend? So pause resume, this will first give the object reference, right? The generator object to the in this g variable. Then when I am doing next g, so what it will do? This is the first next statement. It will first go into this function, and what it will print? It will print the started. Okay, because this is the first line, and then whenever it will fetch the yield statement, it will return the value here Okay, so this will print 1, and now the execution will get stopped. Since yield has done, the execution will get stopped here. Again, when I will do r equal to next of g, so now what it will happen, it will know the last time up to in which point the execution got stopped. So here the execution got stopped, right? It will start after that. That means whenever this next g will encounter, the execution will start from this print statement, because it know last time it got stopped up to this point. From this point it needs to start. So it will print a, again it will fetch EL2, it will return the value here, here it will print 2, again the execution will stop here. So like this, friend, this generator function works. So it knows in previous state how much it has executed, and it will start after that in the next phase. Okay, so let's see this in demo. So till now, friends, any issue, just ping me in the comment section. Okay, if any concept you are not able to understand, I will explain that again. Okay, so first I am writing print, let's say I am giving one step 1 before first yield. Okay, then I am doing yield 1, then I am doing print, let me copy this whole sentence, step 2 before second yield, and I am doing yield 2. Same way, let me do it for the third one, step 3 before third yield, and this is yield 3. Let me clear this. Okay, so tell me, friend, what will be the output for this if I do print next of pause resume demo? So what do you think, friend? What will be the output of this? You can type in the comment section. Just try it once, friend. What will be the output of this? Okay, so technique is before first yield. Okay, Abhishek is telling step 1 and 1. Okay, great. Anyone else can give it a try? Okay. Okay, Nancy is saying step 1. Okay, great. So yeah, Abhishek and Raisi both are correct. So it will be step 1 before first yield and yield 1. So take X, you are also correct. This will also print. But see, yield is also a concept, right? It will also get printed. If you see the concept here, so whenever I am calling the next, okay, on the generator function, it will print from the starting, and yield will also get returned, right? So think yield as a return statement. Okay, so this value is also getting returned, and this will also print. So both it will print. Next time it will print like that. Okay, so if you do the next statement, next pause and demo. Can anyone try again? What will be the output here? Let's see. So what do you think? What will be the output for the second one? Okay, take step 2 of 2. Okay, let's not wait. Yeah, Abhishek, step 2, correct, exactly. So what it will happen in the next step, in Snow, right? In the previous snake, it has up to this one have already been executed. That means it has paused here. Okay, the cursor is here after this point. So it will start from here and it will go until and unless it again meets another yield statement. So this one printed, again it go to yield, done. Again for the next time it will start from this print 3 and yield 3. This will happen. This first one is that step 1 and 1. Then again step 1. Okay, so see another print here. So sorry, this is my fault. So okay, there is another issue, just I wanted to show you again. So for the next function, don't call it with the function invocation. Okay, so just give the reference here. So this is just a type hinting mistake. Okay, function object. Okay, just a second, there is something wrong. Okay, so let's do one thing. So let me first we need to call this and then let's call this with this generator object. Okay, so we are just storing the object here and then we will store this. Now see, it's happening. So first next zip, it's giving me the step 1 before the first yield. For the next, it's giving me step 2 and 2, and for the third, it's giving me step 3 of 3. Okay, so in this way, friend, the generator function works. So I hope you understand how the pause and resume works in the generator function, which is not possible in the normal function. Okay, friend, can you tell me what will happen if I again try to print this in the next line? So what do you think? What it will happen if I again try to print this in the next line? Any guesses, friend? Okay, so many spelling exception. Abhishek is saying error. Yeah, it will start from step 1. Okay, so the actual answer will be like a exception or error, correct? So here it will not give, because see, in the previous section I have also already told, when all the yield statement has returned, okay, the next print statement will give us a stop iteration exception. Okay, so this is the exception it will give. So if I try to again print, see, all the 3 yield has been done, this will give me a stop iteration exception. See, all the thing is done, then it's giving me stop iteration exception. Okay, great. So this is also done. Just one thing, friend. So where we can use this generator, basically we can use this like to read bulk file, okay, data files, or like error log file, all this type of concept. So currently I will not show those things because it will make the video much more long, but if you all want that I will create separate video or a live class on the practical implementation of the generator function, how to implement in real time scenarios, just let me know, huh? Then we can also schedule a session on that. Okay, now another concept is that comprehension. So I hope most of you are aware of, if you are in Python background or have some basic background in Python, you know list comprehension, right? So how does list comprehension works? So basically in one single line we used to create the list, right? Instead of for loop, all those things we will create in a single line. Let's say for x in range 6, and here let's say I wanted a square value of everything. Okay, see, we have created a square value of 0 to 5. Okay, so this is list comprehension, but here again the same issue, we are loading all the data at once in the memory and executing it. So for that, so how we can convert it to a, like for example, generator expression. So this is basically eager evaluation. To convert it to a lazy evaluation, what we can use a generator expression. So how we can use a generator expression? Let's say generator expression. So the code will be everything same, okay, but instead of the square bracket we'll use a first bracket. That's it. Now this is a generator expression. Now if you print, so since it's a generator expression, it will give me a generator object. If I, let's say, print generator expression, see, it's giving me a generator object. Okay, to convert this to a list, either you can use next or you can directly convert this into a list. See, I'm getting the same thing. So for an interview perspective, friend, square bracket is eager evaluation, and if you use a first bracket, so this is a lazy evaluation. Okay, this is known as generator expression. Okay, I hope you got this one, friend, right? So if any issue, let me know in the comment section. Now let's see one of the practical situation. Okay, like I am telling you, right, that normal list will take much more memory, generator will take much less memory, right? How you can experiment? Let's check this one. So let's make another file, memory.py. Okay, here let's take one example where we can check how much memory gets allocated if we are using a list, normal list, and when you are going to use a generator. Okay, so let's see. So one thing to check memory, like how much memory is being used, in Python has one inbuilt module, that is tracemalloc. Using this tracemalloc, friend, you can check the memory consumption of your application, of any variable, of any data type. Okay, we will use this one. So first let's go with without generator. Let's write our dev, let's say without generator. So what we are going to do, friend, we are going to use the same concept. Okay, let's say we are going to create a list of 100 values and we'll check how much memory it's going to take. So let me copy this code itself. Okay, so we have created this code, friend. So what we are doing, so we are creating a list and we are appending 100 values at a go. Okay, Now let's see the memory allocation. Okay, so without generator, how much memory is getting allocated? So how to check that, friend? Before that, let me give you a small introduction how to check that with this tracemalloc. Let's say this is our code block. Okay, sorry. Let's say this is our file, and let's say we have multiple code. Let's say this is the section of code I wanted to check. This section of code I wanted to check how much time it's taking to execute this part. How much time it's taking to execute this part. Okay. So how to check that? So for that, in the tracemalloc, first we need to start it. Okay. So before the function, like from where we wanted to start, before that, we'll start the tracemalloc. Like we'll start the timer. Okay, like this here. So don't confuse it with the timer concept, right? In the last class, we have seen the timer concept in decorator. Timer is a different concept. It's going to see how much time a function is taking. But tracemalloc is a different concept. It's going to see all the variables that are being used, how much memory consumption is happening. Okay. So here we will do tracemalloc.start. Okay, before the execution of the function. Then we will do all the calculation, everything here. Then after everything, what we can do, friend, here we will check. So tracemalloc give us two tuples variables, okay, two integer value. That is, one is what is the memory users currently, okay, like currently how much memory is being used, and what is the peak memory during the execution of this function. What is the peak memory that has been used? Okay, these two values this tracemalloc will give us, and when everything will be done, we can end this. We can stop this. Okay, tracemalloc.stop. That's it. In this way, basically we calculate the memory consumption. Okay, in production application also, if you face any issue like this, you can use the tracemalloc. So let's see. So what is the first step? First step is to start the tracemalloc. Okay, so let me start it. So I have started the tracemalloc. Now let me first call the function, right, without generator. So it will give me a list of 100 number at one go. Okay. Now let me, for example, let me do another operation. Let me get the total value. Okay, let's just sum of 1 to 100. So what we can use? You can use the sum inbuilt method of Python, and we can give this number. Okay. Now we are getting the total number. Now all the operation has been done. Okay. So these two is nothing. So basically these two will stand here. So all the operation has been done here. Now we can check what is the current and the peak memory allocation. So how to check that? We can write tracemalloc dot. So what is this? Yeah, get traced memory. So this function returns a tuple. So two integer value. So that is basically the current memory allocation and what is the peak memory allocation. Okay, and now let's stop it. Tracemalloc.stop. Done. Now let's print it, guys. Now print. Let's say current. What is the value at peak? What is the value? And what is the total? Okay, what is the total sum? Total sum. Let's see. Oh, sorry, it will be not basic. It will be Python memory.py. So see, the current is basically, these are in bytes, friend. Okay, current is 892 byte. So at the peak, is 912 byte. So when is the peak memory allocation will happen, friend? So whenever we are appending, right, whenever we are loading all the data and returning it, that is the peak time. So let's copy it and let's paste it, okay, for our reference. This is the output we have got. Now let's see with the generator function. We will do the same calculation but with a generator function. So this is the same concept. We will use a generator function now. Okay, let me comment this now. Okay, now what we can do, again we can use the same thing. First we will start the tracemalloc dot start, then we will get the generated number. So we can create generator. Then let's see, we will get again the total. So we can use the term sum and the gen. So what I told friend, why this will occur, because there is a concept. See, generators are iterables, okay, and this function accept an iterable. That's why we are able to pass this generator value. Now again we will calculate the current and peak. Let me comment these things also, otherwise you will get confused. And let's now print, let's stop the tracemalloc and let's print it. So what do you think, friend? So what do you think, this current peak, will it remain same, will it reduce, or will it increase? So as per your understanding, what do you think? The same operation, we are doing the same operation, okay. We are generating a number 1 to 100, then we are returning that and we are summing that value. So what do you think, friend? Will this value be the same as the top one? Will reduce or increase? Okay, take it. Reduce. Anyone else? Any guess that it will reduce, increase, or remain same? Okay. So if anyone is confused, let's see what it will happen. See, now the current is 228. Previously it was 892. So what is the peak memory allocation? It's 280. Previously it was 912. So can you see the difference? And the total sum is same, right? The functionality is same. But see this, what is the peak memory allocation? 280 bytes, and that is 912 bytes. So there is a huge reduction, right? So just think, like if we are going to do the same operation of millions of data, how much the performance will improve using the generator function. So that is the reason, go for generator function if you are dealing with heavy large amount of data, okay. As I told you, friend, if you want that practical explanation or anything wanted to see, just let me know in the comment section. I'll create a separate video for that. So with this is the concept of the generator. I hope you got it right. Anyone, any doubt in the generator section? If it's clear, you can write clear, and if any doubt, let me know here, friend. Yeah, let me take just 30-second break, friend. Yeah, sorry, I'm back. Yeah, anyone, any issue, or if everything is fine, just comment it below. Okay, I hope this is clear. If any issue, you can still ping me in the Discord group. Okay, we can communicate there also. Okay, now the next concept is context manager. So context manager is also an important concept in terms of FastAPI, or if you go to the Python interview. So for context manager, we need the concept of this generator. That's why I have introduced the generator concept first. So now the context manager. So what is a context manager? So basically, context manager is a way that it automatically manage resource, okay, like files, database connection, or threading, these type of things. It will make sure if you have opened something, it get closed automatically, okay. Because sometimes what will happen, even if you're home also, you suppose open fridge door and you forget to close that. So what it will happen, if you let it open the fridge door, it will increase your electricity cost, some food may get hampered, right? So that is the concept. So there is some mechanism that you will always close the door, okay. You have some checklist that whenever you open the fridge, you need to close the door. That is mechanism known as context manager. If you are opening something, it will be automatically closed, okay. Let's say the fridge company implemented something, if the door is opened, it will automatically close, okay, like that, a sensor type of concept. So that is basically the context manager. So first let's see a basic example. Let's say first how we used to do manual resource management. So what does this means? That manually we used to manage the resource, like we used to open that, we used to close that, right? That is manual resource management. So let's take one example. Let's say the file management, okay. I wanted to write something in a file. So how we need to write? Yeah, A3R Dev, hi. Yeah, any question, Shadab, you can ping in the chat group, okay. I'll try to resolve that. And thanks for joining. Okay, so this is file. So how we used to do? We need to use a try block. Then we need to open the file, right? Open. Let's say there is a test.txt file, okay. So even the file is not there, it will automatically create the file, okay. And I wanted to write something into the file. So there are different mode available in the file: read, write, append, everything. So just I want a simple write mode. So now I wanted to write something. Let's say file dot write. Let's say hello world. Now I have opened the file. Okay, here the file is open. So here the file is open, right? Now it's our duty to close the file. Okay. So what will happen? You can write close file here also, right? Let's say here you can write the file.close. But what will happen? Suppose say if any exception occur here in line number 7, then this file close will never come, right? The exception will occur here and the file will never be closed. That means the resource get opened and it is just blocking your memory allocation. So how we are going to fix this thing? So here we will write a except block. It can handle any type of exception. So I'm writing one generic exception. So just I'm printing it. And then in the finally block, I'm checking if the file is open, okay. If there is any reference to this file, that time I'll close the file. This is a manual resource management. That means I am opening the file and I need to close the file by myself. Okay, I need to check every edge condition. If any exception occurs, that also I need to fix. Everything I need to do manually. Okay, this is the way we used to do. Let's see if this is running or not. Python. Okay, see, the test.txt, the hello world file has been created. Okay, so everything is working fine and the file is closed also. But this is we are doing manually. So what is the solution? Because sometimes the developer will forget to close this, right? This one or any database connection. So if this happens, the memory is wastage. So to reduce this error, Python has introduced this context manager. Okay, that means how this context manager will occur. So Python is giving us a with keyword. Okay, so with this with keyword, so if you hover over this with, okay, it's not giving any reason. So this with keyword will do all the resource management. Okay, that means if you open something, it will automatically close that. You don't need to close that manually. So let's say for the same thing, let me delete this file. So here, what we can do, sorry, with open. Okay. So this open we are doing, so we are trying to open a file. Okay. Let's say again the test.txt, and we need to open this as a write mode. Okay, we wanted to write something, and I'm storing it into a file. Then I'm doing file.write. Hello world again. Let me do a print statement. File written. Okay. And then what we'll do, here basically the file will be closed automatically. Okay, you don't need to write file.close because the with statement will automatically close the file. So basically so this is I'm just writing manually now, but this is automatically happening with the with keyword. File closed automatically. Okay, so file is written and the file will be closed automatically. Okay, hello world is there. Okay, sorry, there is a comma, I have written it wrong. So this is a context manager. But let me, for the interview perspective, let me give you another example to how to create your own custom context manager, because this is in interview, many interview will ask this question. Okay, so how to create your own context manager. So let's create a context manager, our own file context manager. Okay, so this with method basically this with method basically calls two magic method, that is underscore enter and underscore exit. These are the two magic methods this with function calls. Okay, so let's create one custom implementation. Okay, so basically I will also give you what will happen. So whenever you are writing this one, right, with open this line, so whenever you are writing this line, so basically what is happening, so first it will go in the enter underscore enter. Okay, that means it's entering phase, so it has entered. Okay, so basically this is the value, this file. Then after enter, all your code will run. So you will write your code logic. Okay, then when your code got executed, it will automatically call the exit underscore exit. It will automatically call. Okay, basically here like it will be always called. Okay, even on error also, even if any error occurred, this exit will get called. Okay, so let's see this, let's implement this one. So let's do So what we are implementing? We are implementing this with open, right? We are implementing our own file manager, file context manager. So let's first create a class, file manager. So let's create one init method, that is a constructor method. Okay. So here we are going to take the file name and the mode. Okay. So mode means we wanted to read it or write it or append it. That is the mode, friend. Okay. So here we will write self dot file name equal to file name, self dot mode equal to mode, and let's say self dot file. To get the reference of the file, we are going to open. Okay, first it will be none, right? Because we are not opening any file initially. Then there is a magic method, def enter. So here our all the logic will be written here, friend. Okay. So let me give print enter. Okay, that means opening the file name. Let me give the file name self dot file name. So here whenever we are opening it, first it will go to the enter block. Then here what we will do, like self dot file, sorry, file equal to, so we wanted to open the file, right? Open. So we will give the file name self dot file name and the mode self dot mode. Is it read mode or write mode? Okay. And here from here we need to return the file. So we need to return the value, friend. Okay. So here see we are writing, right, with open as file. So where this file is coming from, friend? So this is coming from this enter. So this enter must return a value. It should return a value. Okay, so it should return a value. Now when all the code will be executed, the exit block will get called. So print exit block. Okay. Now exit block will take two different parameters, not two, three different parameters. First one is exception type. Like what type of exception has occurred. Okay. Then exception value. And then a traceback, like where, in which line number, those type of things. Okay. It will take three parameters. See, if there is, so why these things? Like if any exception occurred, you can manually handle that. So if there is no exception, we can simply check if the file is open. Just close the file, self.file.close. Okay. But if there is any exception, like if there is any exception type is there, you can handle that. Okay, you can handle the exception here. But let me just print that value. Here in exit, exception value is exception value. That's it. This is how you create one file manager. Okay, context manager. Now how to use this context manager? So like we can write with file manager. Here you can give the file name, right? So let's say the file name is, let's say, abc.txt file. And what is the mode, friend? We wanted to, let's say, write it. Okay, we wanted to write it. Then since whenever we are writing this line means the interface. Okay, so this interface is returning one value, right? So that we are going to assign it as f. Okay, now we are writing f.write, let's say Superman. Okay. And then we will write print file written. Now let's run this, friend. So let's see what will happen. See, first it has gone to enter block, right? In the enter block, and it's opening the file, that is abc.txt. Then this operation occurred. Okay, this operation occurred. Then what happened? The file is written. When there is nothing else, it has called the exit block. Okay, it has called the exit block, and it has closed the file. Since there is no exception, so that's why it's closing the file. But let's say if there is any exception, what will happen? We wanted to read the file. What is the content of this file? So what we can do, with file manager, let's see abc.txt, and now we wanted to read it, right? We wanted to read it now. Let me comment this as if, let's say content is equal to f.read. Okay, now let me print the content. And now let me manually raise one exception. Raise a value error. Okay, testing error. Let's say, give me a testing error. Okay, let's see what will happen now. See, it has entered, opening ABC text. See the content. It has read the content, right? Superman. But in the exit block, see, exception value is testing block. That is this one. So if any exception occurs, see, we are handling the exception also. In this way, like you can write your own logic, okay, with the exception type. So in the exception type, you can write if exception type is value error, you can handle in that way. If exception type is your custom manual error, you can handle it that way. Okay. So in this way, you can create your own context manager. So I hope you got it, right? Now the final concept is the context library. Okay, or contextlib. So what is that? Next is contextlib. So this is a simpler version, friend. So in context manager, basically we are returning a file, right? But what will happen if we are going to use a generator, like we are going to yield it? In that case, mostly we don't use this class file context manager or a context manager in a class concept. Okay. In that case, we basically use a contextlib to use the generator concept. So here, how to write? So from the context manager, so let me, from contextlib import context manager. Okay, so this is the context manager. Sorry, this is the context manager coming from this contextlib library. So this helps us to handle the generator. Okay. Now let's say we are going to do the same file manager concept using a generator concept. So how you can do this? You can write a function. Let's say file manager. So here we will give the same file name and mode. Okay. But here you need to handle the exception with try catch block. Okay. So let's say before yield. So now if equal to open the file name and the mode. Okay. And then we will do try yield if. Okay. And then we also need to raise a finally block if dot close. Okay. So here you can write print after yield. So in this way, friend, you can basically write. Now how to make this as a context manager? So you need to just decorate it with the context manager. Now it will handle your opening and closing. Okay. So now you can do the same concept like with this file manager. Okay, let me give another demo.txt in write mode as if, and here you can do if.write okay, and then you can do let's say testing. Okay, so in this way, so let me check if it will work or not. Okay, see demo.text, the testing is there. So in this way, friend, you can use the yield concept, that is the generator concept. So what will happen? So this yield block, okay, so this is acting, everything before this will act like a enter statement, underscore enter. Okay, yield value is basically the variable, this f, okay, this is returning. Yield is basically the return statement. Here we are returning, right? In the enter, returning the value. This yield is the same here, it's returning the value. And after yield, whatever you have written, that is basically the exit block. This is the concept, and we will use this very much in the FastAPI, in the context management. So before this yield, everything will run at once, and after, whenever the execution is completed, this will get executed. So where we will use this? We will use this in database management. Let's say here we will open the database. When the application gets closed, the database will be closed. Like this type of concept, we will use this context manager. So there manually we don't need to close those things. So I hope everything is clear, friend. So yeah, up to this we have completed the generator and the context manager. So now with just one or two concepts, we can we can officially enter into the FastAPI. There now you will understand each and every concept, like there why you are using this context manager, then why we are using the decorator, everything. So if any question, let me know, friend, in the chat. Now the Q&A section is open. If anyone have any question, you can ask here, or later on also in the Discord group you can ask your query, and if not, we can close the session. Okay, TechX is saying cleared. Okay, anyone else? Any issue or question, just let me know. Okay, if there is no question, then thank you guys for joining the session. Hope you have learned something in this session. So I will again schedule the next class, and I'll just inform you all. You will get notification. Just subscribe it, okay? And if you like the video, please comment it something, okay? Whatever your feedback is in the YouTube comment or in the LinkedIn section, just comment it. Okay. Thank you guys.